8 teams enter a tournament, and every team plays every other team exactly once. Draw one line for each game. Watch the fixtures pile up, pair after pair. So how many games does the whole tournament need? Go ahead and try to count them in this tangle. It is genuinely hard. The lines cross and overlap. You lose your place. You count one twice or skip another. Count it 3 times and you will likely get 3 different answers. So do not attack it head-on. There is a method mathematicians reach for again and again on problems far harder than this one. Shrink the problem down to its smallest cases, the ones you can count on one hand. Find the rule there where nothing can hide, and only then come back to the big one. Start as small as it goes, 2 points, join every pair, and there is only one pair, so one line. Nothing to miscount here, nothing to tangle. This is the kind of case where the answer is simply obvious, and that is exactly what we want to build on. Add a third point. It joins to both points already there, so it brings 2 new lines. 1 from before plus 2 makes 3. The new point reaches back to everything already sitting there. A fourth point joins to all 3 before it. 3 new lines this time, so 3 plus 3 is 6. The same idea keeps working. Each newcomer reaches back to every point that was already there, and nowhere else. A fifth point joins to all 4 before it. 4 new lines, 6 plus 4 is 10. The counts so far run 1, 3, 6, 10, and each jump is a little bigger than the last. Look at those jumps. Going to 3 points added 2, to 4 added 3, to 5 added 4. Every new point adds 1 line to each point already there. So the nth point adds n-1 lines, and the total is just those jumps added up, 1 plus 2 plus 3, all the way to n-1. That is the rule, guessed from nothing more than 4 tiny pictures. But a guess is not yet a fact. It has to earn our trust first. Before trusting a guess, test it on a case you already know. 5 points. The rule says 1 plus 2 plus 3 plus 4, which is 10. And counting the small picture directly also gave 10. The 2 answers agree, so the guess holds. Now we can be bold and use it. Back to the 8 teams that started all this. The rule says add 1, 2, 3, 4, 5, 6, 7. That sum is 28. 28 games, and not once did we have to untangle the full picture. The small cases handed us the answer, clean and certain. That is the whole power of it. The hard case never got any easier to look at, but we never needed to look at it. We built the answer from the ground up instead. There is even a shortcut for that sum. Each of the 8 points touches the other 7. That is 8 times 7, 56, but every line got counted from both of its ends. So halve it, and you are back to 28, matching the sum exactly. And 100 points? 100 times 99, halved, is 4,950. Try untangling 100 points by eye. You never could. The method does not flinch at big numbers at all. That halving is exactly the trap in counting the tangle head-on. Each line has 2 ends, and it is far too easy to count it once from each end and finish with double the real number. Building up from the small cases quietly sidesteps that. You add each new point's lines exactly once, in order, so nothing gets counted twice and nothing gets skipped. That is why the method is safe as well as fast. It keeps the counting honest. So here is the whole method, the one worth keeping. When a problem is too big to see, shrink it. Do the smallest cases, the ones you can just count without any tangle. Watch how the numbers grow and make a bold guess at the rule. Test that guess on a case you already know the answer to. Then, and only then, apply it to the big one. Shrink, guess, verify, apply. That short chain solves problems that look completely hopeless head-on. Your turn with a problem that looks completely different. 11 straight lines, no 2 parallel, and no 3 through 1 point. What is the greatest number of crossing points they can make? Shrink it first, then pause. 2 lines cross once. A third crosses both, adding 2 for 3. A fourth adds 3 for 6. The same 1, 3, 6 pattern. So 11 lines give 1 plus 2, up to 10, which is 55. A new problem. the very same rule. One more and a completely different setting. 6 cities with a direct flight route between every pair of them. How many routes is that? It is the same shape as points joined by lines. Shrink it, guess, and pause. Each new city links to all the cities before it, exactly like each new point reaching back. So 1, plus 2, plus 3, plus 4, plus 5. That is 15 routes, same method, same climbing sum, a completely different dressing. Once you spot the shape, the answer is already yours. This shape is everywhere once you know to look. Handshakes in a room where everyone greets everyone once. Cables joining every computer to every other. Fixtures in a round-robin season. All of them are just points joined in pairs, and all of them land on that same climbing sum. And the method behind it is bigger than any one sum. Anytime a problem is too large to see, shrink it to where you can count and build back up. So when a problem looks like an impossible tangle, do not stare it down. Shrink it to its smallest cases. Find the rule where counting is easy, check it, and carry it back up to the big one. That's all for this video.